Bismillahirrahmanirrahim. Now we will continue with exercise 2.3. We did up to question number 4. Now in question number 5 we have find the value of m if the roots of the equation x square minus 7x plus 3m minus 5 is equal to 0. We are given the equation and they want us to find the value of m if the roots of the equation satisfy the relation 3 alpha plus 2 beta is equal to 4. So here alpha and beta are representing the roots of this equation, and it is said that the roots of this equation, which are denoted by alpha and beta, they satisfy this equation. So using this condition we are going to find the value of m. 1, 2, 3, all these parts have the same method, so I will do part 3 for you, and part 1 and 2 will be the same as part 3. You can follow the same method in order to attempt part 1 and part 2. So question number 5 part 3 is question number 5 is the equation that is given to us is 3x square minus 2x plus 7m plus 2 equals to 0. Okay, and it is said that alpha and beta are the roots of this equation and they satisfy the equation 7 alpha minus 3 beta equals to 18. We have to find the value of m. Okay, and it is given to us that 7 alpha minus 3 beta, this, let me denote this by equation 1. Now let's start with the solution. Now we know that from the relation between the roots and the coefficients of this equation, we have a equals to 3, b equals to negative 2. This is I am writing the coefficients. Okay, a, the coefficient of x square is 3. I am denoting it by capital A. Capital B, the coefficient of x by capital B, which is negative 2, and the constant term is equal to 7m plus 2. Okay, so now we know that sum of the roots is equal to negative b over a, as we have already studied this in the previous lecture. The sum of the roots is equal to negative of the coefficient of x over coefficient of x square, which in this case will be negative. B is negative 2 and coefficient of x is 3. It means that alpha plus beta will be equal to 2 by 3. Now they are asking for the value of m. Okay, so it means that we will require an equation in m in order to find its value, and that equation should be such that the only unknown in that equation should be the letter m, not any other unknowns. That is the only case we can find the value of m. Now we know that product of the roots is equal to c by a, which is in this case is c is 7m plus 2, okay, the constant term, over a is 3. Now alpha into beta is equal to 7m plus 2 over 3, or this can also be written as 3 times alpha into beta is equal to 7m plus 2. Now from here we can find the value of m, but the problem is that we have two other unknowns in this equation, alpha and beta, which are the roots of the given equation, and we don't have their values. If we somehow find their values, we can easily put the values of alpha and beta in this equation and get the value of m. So our next target will be, let me name it as equation 2. Our next target is to find the value of alpha and beta so that we can put the value of alpha and beta in this equation and get the value of m. Now we know that over here we have alpha plus beta is equal to 2 by 3. Okay, consider this equation and the equation which they have given to us. We can solve these two equations simultaneously to get the value of alpha and beta, which we will use in this step. Okay, this is what we are going to do. So over here we have two equations. The one which is given in the equation 7 alpha minus 3 beta is equal to 18. We need alpha and beta. These are two unknowns. In order to find two unknowns, we have to find two equations in alpha and beta. Okay, the number of equation must be more than or equal to the number of unknowns in order to find them. Over here we have two unknowns, so we need two equations for alpha and beta. One equation is this one which they have given us in the equation, and the second one is this equation which we know from our previous knowledge, that the sum of the roots is always equal to negative of coefficient of the coefficient of x over coefficient of x square, which is 2 by 3. So from here we know that alpha plus beta is equal to 2 by 3. These are the two equations which will help us to find the value of alpha and beta. I am going to get the values of alpha and beta from these equations, and then I am going to put them in this equation to get the value of m. Okay, and we will solve it simultaneously as we did before. We can use substitution method as well as the elimination method to solve this equation. I am going to use substitution method. Let us use substitution method. From here I can take the value of alpha as 2 by 3 minus beta, and putting the value of alpha from this equation in equation 1, we will get 7, and alpha is 2 by 3 minus beta. Putting this value of alpha in the equation 1, 2 by 3 minus beta minus 3 beta equals to 18, and this will give me 14 by 3 minus 7 beta minus 3 beta is equal to 18, which will in turn give me the equation 7 beta minus 3 beta will be negative 10 beta. I can add these two because signs are same, so negative 10 beta will be equal to 18 minus 14 by 3. 18 minus 14 by 3. Now this will be equal to 10 beta equals to 18 minus 14 by 3 will be, by using the calculator we can find 18 minus 14 by 3, 14 by 3, and this will give me 40 by 3. So beta will be negative 40 by 3 into, shifting this 10 to the right hand side, we will get this, cancelling out the zeros, we will have beta equals to negative 4 by 3. As beta is equal to negative 4 by 3, so putting the value of beta in this equation, we are going to get alpha equals to 2 by 3 minus beta. So it means alpha will be equal to 2 by 3 minus 4 by 3. This sign will become plus, 2 by 3 minus plus. So in the next step what we are going to do is we are going to put a plus sign over here, and 2 by 3 plus 4 by 3, we know it is 6 by 3 equals to 6 by 3, which is equal to 2. So the value of alpha is equal to 2. Okay, so we have the value of alpha and beta now. In order to get the value of m, I am going to put the value of alpha and beta over here, and then it will give me the value of m. So what do we have over here? Alpha is 2 and beta is negative 4 by 3. These are the values that we obtained from our calculation. Now in the next step I am going to use these two values in this equation in order to get the value of m. So taking equation 2, we know that 3 into alpha beta is equal to 7m plus 2. Putting the values of alpha and beta in this equation, we are going to get 3. Alpha is 2, beta is negative 4 by 3 equals to 7m plus 2. 3 will be cancelled out with 3. This will 2 4s are 8 is equal to 7m plus 2, which implies that 7m will be equal to negative 8. Shifting this to the left hand side, we are going to get this, and 7m is equal to negative 10, and m will be equal to negative 10 by 7. Okay, so this is the value of m. So this completes the question. They had asked for the value of m, and we have found out the value of m. Now moving to the next question, question number 6. Question number 6 is that find m if sum and product of the roots, sum and product means alpha plus beta and product means alpha into beta of the roots of the following equation is equal to the given number lambda. It means that for this equation, if alpha and beta are the roots, then their sum means alpha plus beta and the product alpha into beta, they are equal to the same number lambda. Okay, so this is the equation. I will do the second part for you. Okay, in the same way you can do the first part. In the second part, the equation is 4x square minus 3 plus 5mx minus 9m minus 17 equals to 0. Okay, now it is given to us that the sum and the product of the roots both are equal to lambda. Okay, so if alpha and beta are the roots of the given equation, let alpha and beta be given equation. Now according to them, the sum of the roots, that is alpha plus beta, this is the sum, is equal to the product of the root, and both are equal to the letter lambda, the number lambda. This number is also unknown. Okay, but we know that if these two are equal to lambda, then they must be equal to one another. So it means that alpha plus beta and alpha into beta are both equal. Okay, mark this as equation 1. Now from the given equation, we know that the coefficient of x square is 4, coefficients of x is negative 3 plus 5m, and coefficient of constant, the constant is, which is the coefficient of x raised to the power 0, is this equation, which can be written as 9m plus 17, negative 9m plus 17, and which in turn we can write 17 minus 9m. So this is C. Okay, so over here A is equal to 4, B is equal to this number, and C is equal to this number. Okay, now we know that the sum of the roots is equal to negative b over a. It means that it will be equal to negative b is this expression, which will be equal to positive 3 plus 5m. So this implies that alpha plus beta will be equal to 3 plus 5m. Let it be equation 2. Now we know that the product of the roots is equal to the ratio of C and A. This implies that alpha into beta will be C is 17 minus 9m over A is 4. So this is equation 3. Now putting the values of alpha plus beta equals to 3 plus 5m and alpha beta, values of alpha plus beta and value of alpha into beta in equation 1, we will get from equation 1 alpha plus beta is equal to alpha into beta. This was equation 1. So putting the value of alpha plus beta from equation 2, we have 3 plus 5m. Because we have to find the value of m, so we have to find an equation in m. Okay, and the condition which is given to us is that both these are equal to lambda. So if they are equal to lambda, they must be equal to one another, and this is the fact that we are using to find the value of m. 3 plus 5m is equal to alpha into beta is 17 minus 9m over 4, multiplying 4 to this side. Let me erase this. Now let me write this equation again. 4 into 3 plus 5m equals to 17 minus 9m. Okay, so now we are going to solve this equation by simple shifting method. Okay. 3 4s are 12 plus 20, m is equal to 17 minus 9m, and 20 m shifting 9 to the left hand side. 17 minus 12, this will be 29, m equals 17 minus 12 will be 5, so the value of m will be 5 by 29, and that is what they had asked us to calculate. So this is the answer, and this completes the solution of question number 6 as well as exercise 2.3.